So first step, we know that 1 mole of this will react with 1 mole of this. The question is, how many moles do we have here? Now you could, the group in the back there, went from moles per liter to liters, did a mole to mole ratio, did moles back to grams, got an answer for this conversion. Then they used this as their limiting reactant. They did molarity units to moles and moles to moles and moles back to grams of this. So they picked the smaller of the 2 answers. That way works fine. Sometimes I will work the problem that way. I didn't, though, in this situation. I worked it a little bit different. Let's see how many moles of this we have. So here we go. We know that you will have 1.2 moles in every liter. Do we have a liter? No, we only have 0.3 liters. So how many moles of our sodium carbonate do we actually have? Do the math, 0.36 moles. I'll do the same thing over here. How many moles of this do I have? Just a quick calculation. We have 0.8 moles if we had a liter. Do we have a liter? We've only got 0.4 liters. Do the math there. You have 0.32 moles. Now you can immediately see the limiting reactant. 1 needs 1, 1 needs 1, 1 needs 1. So, who's the limiting reactant? This is our limiting reactant. This is in excess. Dun, 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 dun. Want me to sing the song?
Yeah.
No, I'm not singing the song. It's our limiting reactant. Now I can fast forward. 1 makes 1. What's 0.32 going to make? So my answer is 0.32 moles, but I want it in grams, so I'm just going to do that conversion quickly. We will make 0.32 moles of calcium carbonate, change moles to grams. Hey, it's a nice number, 100. 0.32 times 100, 32. People, you will make 32 grams of the gosh dang precipitate. Comprende? Now that's a straightforward calculation. I hope you can wrap the brain around that one. I'll put this up on YouTube. You can review at your leisure. For fun tonight. Okay, now, how much of these ions are floating around in the solution? And not only how much, but how many moles are in each liter? Well, you know what someone's going to say? We don't have a liter. We got 700 milliliters. You're right. That's why each of these is going to get divided by 0.7. Divided by 0.7. Divided by 0.7. Divided by 0.7. All we have to do is find the number of moles. Put that on the top. Let's do sodium first. It's a spectator. Anybody want to take a wild guess how many moles of sodium we're going to have?
Well, then you would do half of it. So.
Half of it or double it? 0.36 times 2 divided by 0.7. Done. 0.36 times 2 divided by 0.7. What'd you get? 1.03. There's our concentration. I'll say it again. When we put this in a water solution, it's going to dissociate and give you double that mole value. Because 1 makes 2. Every time you take a bike apart, you get 2 tires. If you took 36 bikes apart, you'd get 72 tires. Let's go to carbonate. Carbonate. Now, carbonate is tricky. Much of the carbonate is used up. And it falls to the bottom of the beaker as part of the precipitate. Are you with me? Not all of it's used up, though. There's some leftovers. Guess what we're having at the Caliber house tonight for dinner? Beef soup. It's leftovers from last night. People, 1 uses up 1, 1 uses up 1, 1 uses up 1, 1 uses up 1. What's 0.32 gonna use up? 0.32. If we use up 0.32 of the 0.36, how much is left over? 0.04 moles left over. 0.04 divided by 0.7. What'd you get? 0.063. That's what I got. It's a very small concentration because most of it got used up. Comprende?
Sí, señor.
Chloride ions. All of the chloride ions are going to come from calcium chloride. It's a spectator. None of them get used up. Hey, it's a 2. From this 1, we'll get 2. From 0.32 moles, we'll get... I'll say that slower. 1 makes 2, 1 makes 2, 1 makes 2, 1 makes 2. 0.32 moles will make 0.64. Hey, you can do the math there, people. What'd you get, like 0.91? Hey, that's what I get. And now my favorite, calcium. Calcium is going to get used up and fall down in the precipitate. How much? All of it. All of it's going to get used up. It's the chocolate of the s'mores world. Are you with me? It's not only the limiting reactant, it's also the precipitate. We're going to have none of that left. There you go, final answer. Study up.